I'm Steven Dilly, I work at Mirego. I just want to introduce Mirego real quickly. We're a solutions company that works with other like big brands. We're a dynamic team, and some of the projects we do, for example, we have IGA, Air Transat, Family Prix, SAQ. We have a lot of projects. I think we have like more than 100 or 200. You can see it in our website, and we're really a complete solution from strategy to the actual applications and project. So that's it for Mirego, and tonight I'm going to present Jetpack Compose recompositions. So first, I'm going to talk about how recompositions work, and then we'll see how to prevent recompositions. And followed that is a couple of examples and a small recap at the end. So, how do recompositions work? First of all, let's talk about the Jetpack, the three phases of Jetpack Compose. So first, when you're creating a layout, what Jetpack Compose does in the background is the composition phase, the layout phase, and the drawing phase. So the composition phase can be summarized with the keyword what. What UI to show. So compose runs composable functions and creates a description of your UI. So basically, it does a map of a parent and children hierarchy and determines the links between them. The layout phase is where to place the UI. So this phase consists of two steps, measurement and placement. Layout elements measure and place themselves and any child elements in 2D coordinates for each node in the layout tree. So you see where the UI will be placed, but it isn't drawn yet. And the drawing phase is how it renders. UI elements is drawn into a canvas and then you see it in the screen. So this is your full UI. So recomposition, it happens when certain states change. It can also happen if the UI layout changes. So like if you add a child to a parent, recomposition will occur for that node. Recomposition retriggers all three Jetpack Compose phases. And depending on the UI hierarchy, that can be costly. So just a small disclaimer before continuing, recomposition is not evil, so I'll talk about how to prevent some recomposition, but some are actually essential. So there is no war against recomposition. For example, if you modify a text in a text field, or if you click on a checkbox, the state of these composables will change, and that's perfectly fine, that's normal. So, how to prevent useless recompositions. So first of all, you can use the keyword remember. So here we have a composable contact list with a lazy column and items that takes a list of contacts. Now the problem with this is that the contacts is sorted every time the contact list gets recomposed. So what you can do to prevent resorting every time is you can use remember with the keywords contacts and sort comparator. So what this does is that the contacts will remain sorted as long as contacts and sort comparator stay the same. Because in the earlier example, even if the list did not change, it would still resort. But with remember, it will remember that the list is sorted if nothing changes. So remember doesn't actually prevent recomposition, but it will prevent useless computation when recomposition occurs. Next is use derived state of for frequently changing states. So in this example, you have a lazy column, which is kind of a list view, and you want to show a button if the first visible item index is more than 0. So once the user has started to scroll. Now the problem with this is that the first visible item index is a state, and every time you change the state, the composable will recompose. So even though you don't care after the first visible index is bigger than 0, then you'll still recompose at 1, 2, 3, 4, and it's pretty useless. What you can do is wrap it with a derived state of, and what this does is that it will only recompose if the body of derived state of changes. So this is perfect if you have a Boolean condition, or if you have a state that changes within ranges of numbers. So in this example, it will not recompose if it's anything above 1 once it has recomposed the first time. Next is to use lambda modifiers. So in this example, we want to change the alpha from a given state, and then we use the modifier alpha to update the text. The problem with this is that modifiers with a parentheses are called during composition. So you will recompose every time the changed alpha changes. So to fix this, you can use the graphics layer and modify the alpha this way, because the lambda modifiers are called during the drawing phase. So it skips the composition and layout phase, which is way better for processing, for rendering, sorry. So how do we see recomposition data in our app? Starting in Android Studio Electric Eel, in your layout inspector, you can actually see the recompositions as you navigate on your app. So first of all, you have to click on the little eye icon on the blue, shown by the blue arrow, and then make sure that the show recomposition counts is checked. When that's done, you can just navigate through your app and you will see numbers appear if there's recomposition. So in this example, the left numbers are the recompositions of the view, and the right numbers, which are a little bit grayed out, is skipped recompositions. So there's a little bit of Jetpack compose magic where the view itself can decide if it needs to recompose or not. Okay, so let's go with a first example. So here we have an app which is a lazy column, so a list view, and there's a blue header on top. Now, what we want to do here is when we scroll the lazy column, once we don't see item 0 anymore, we want to change the color to red. So if we check the header code, here we see the code, the color target value is first visible item index equals 0, show blue, else show red. And then we put the color in the modifier background of the box. So let's see what happens when I scroll over here. So we're just doing a back and forth here. We'll wait for the GIF to restart. So we're just doing a back and forth here, and I'm expecting 2 recompositions, one for each state change. So once it gets red, and then once it gets blue. But here I have 33 recompositions. So let's check what's happening. As we saw earlier, when checking the first visible item index, it is better to wrap it in the derived state of block so that we don't need to recompose after the first visible item index is higher than 0. So the problem with the code is here. So if we change it, we use the first item visible and we use derived state of. So now this block will not recompose every time it's higher than 0. It keeps higher than 0. So let's see what happens now. There's still a lot of compositions, but it's better. It's not 33, this time it's 20. So what can we do now? The problem is another thing we talked earlier is modifiers. So we're using a background modifier which uses parentheses. So this has to be changed in the composition phase. We can use another modifier which is draw behind. So what this lets us do is color the background of the box, which is essentially like the background modifier, but since it's a lambda, it will only be run on the drawing phase, so it will consume less UI rendering energy, I guess. So here we see that it actually works. So there's two state changes. So there's two recompositions. Yay! So let's check example 2. It's essentially the same thing, except that we don't change the color of the header. We actually do a kind of a seek bar effect. So now, instead of just ignoring all indexes, like last time when we had only blue and red color, now we have to check the state for every scroll offset. So the code is very similar. We have a scroll percentage that is calculated for the offset of the bar. We have a box with constraints that represents the outer outline box, and the inner box is the scroll bar that moves. So if we navigate, we scroll a little bit, we notice that there's a lot of recompositions, which is kind of normal because the state changes a lot. So what can we do to help with this? Actually, we're still using a modifier with a parenthesis with the offset. So that's something that we can change. We cannot use derived state of for the scroll percent because this isn't a Boolean type condition that we can just check, since we have to watch for every change of the scroll. But just changing the offset, we can use actually offset comes with parentheses or lambdas, so you can use the lambda version, and you can also calculate the scroll percent inside the lambda. This will make it so that only the drawing phase will be aware of the scroll change. So you don't recompose every time the offset changes. You only redo the drawing phase. So if we check here, beautiful, no recomposition, perfect. So just to recap, use the layout inspector in your app to make sure that there's no crazy recompositions going on. Use remember to prevent heavy computation once recomposition occurs. Use derived state of for fast changing states like the scroll that we saw earlier. And use lambda modifiers when possible so that you skip the composition and layouting phases. So usually recomposition problems majorly refer to these steps. So it's usually the same thing every time. So that's it. Thank you.